Hi guys, welcome to the askIITians video series. So my name is Yash Pahiti and today we are going to study about the chapter functions. So the most important concept in the chapter function is about range and domain. How to find out range and domain of some functions. Now in order to find out range and domain, first we have to study, or first we have to get a clear idea of what range domain is, and then there is also another term that is called codomain. So there are three terms: range, domain, and codomain. Now we'll study. The best method to study is to study by the sets. To imagine by taking examples of sets that how they can be solved, the questions can be solved, and what is difference between all these three terms. So what we have here? We have here, let's say, set A and set B. Now, suppose that there exists some relation. Now, if this relation has to be a function, then by the definition of function, we know that each and every element of set A must be mapped with unique element of set B. That is the definition of the function. So we are going to assume that each and every element, that means all these four elements are mapping with at least one, mapping with only one element here. Okay, so that the mapping will be unique. Now, if you again let's take an example to study this thing. So there are three terms, as I've said, that domain, okay, domain, codomain, and range. Okay, so let's say that these elements and these are unset. Now take an example of a machine. Okay, suppose that we have a machine. We have a machine that gives us plastic toys as an output. So we have a machine that is giving us plastic toys as an output. Now in order to get plastic toys as an output, we have to provide some raw material. That raw material is input. Now what that raw material can be? Obviously, because the toys are made up of plastic, the raw material has to be plastic. So plastic is a valid input. Plastic is a valid input. Now suppose that if you try to put in some of any metal instead of plastic, then the machine won't be able to make the toys, because machine doesn't know how to process any metal. Machine knows how to process the plastic and to give an output of plastic toy. So machine cannot take metal as an input. So that is an invalid input. So there are two things. I hope that you have understood by now. One is the valid input and one is invalid input. Okay. Now domain. Domain is all the valid inputs. Domain is all the valid inputs. Now suppose that if this relation is a machine, so I can say that each and every element of this set A is mapping to some element. Each and every element of this set A is mapping to some element. So let's say that we said that okay, let's say that this is this machine. This is this machine. So each and every element is mapping. We have to map each and every element. That means each and every element of set A is a domain. Each and every element of our set A is domain, because in order for this relation to be a function, all these elements have to map. So that means all these elements are an input. So that means all the valid inputs, these are nothing but elements of set A. These are nothing but elements of set A. Okay. Now we are giving some input. Why we are providing any raw material as an input? Why we are doing this? We are doing this to get an output, to get a corresponding output. Now if why we are not placing any metal or any other thing, it's because that there is no output corresponding to any metal is metal. any metal is a raw material, there is no corresponding output. So that is why we are not giving input as metals. But if we are putting the correct inputs, then we have to get the corresponding outputs. Now, there are two things. Suppose that if this is the machine, I don't know what is my mapping. So, what I am thinking is that all the elements of set B are my possible outputs. They are my expected outputs. I am expecting that any or all of these 4 elements will be mapping. I don't know. So codomain is nothing but expected output. I don't know actually that what is my output, but I am expecting that any of these elements will be output. So I don't know, so I cannot exclude any of the elements. So I am saying that okay, all the elements of our set B are our expected output. All the elements of set B are my expected outputs. I mean, till the time I know mapping, I cannot say that okay, this is mapping and this is not mapping. So I am expecting that any of these elements can be my output. So codomain is expected output. What is the output that you are expecting? That is the codomain. Now suppose that we proceed with our mapping, and if our mapping is like this. If our mapping is like this, then obviously we expected D to be as output as well, but D is not our output. So here comes the range. Range is actual output. Range is actual output. That's it. Range is my actual output. The output I am getting. Now always remember that range is actual output, but codomain is expected outputs. Your expected set will be always greater than or equal to your range. This whole set is codomain, but range is a part of codomain. Remember that. So I can say very clearly that range is a subset of codomain. Obviously, because codomain is your whole set and range is a part of this set. So as I've said, domain is the input. Think in terms of machine. Domain is the input, codomain is the expected output, and range is the valid output. Okay, I'll tell you later on that what do we mean by valid outputs. Okay. So I hope that this is clear to everyone. Now let's move. Now let's take an example to understand that what this concept is trying to tell us. This is the very basic. This is the basic definition which we have provided in terms of sets. But now let's try to put it in a function. Suppose that I have a function y is equal to x squared. Suppose that I have a function y is equal to x squared. Now, for this function, obviously I am placing the values of x. So x is my input, and I am observing the values of y. So y is my output. Now, so this is input. That means the set of values of x is my domain, and this will give me codomain and range. Now, from domain, look, I can place any value of x. There is no problem. I can place any values of x. There is no problem. Any value, I can place any value. So let's say I can place a very huge negative value. I can place a very huge positive value as well. I can place 0 as well. So my domain is R. That means all real numbers. My domain is R, all real numbers. Now my codomain, I am expecting it to be R as well. Look, we have to expect a bigger set always. We have to expect a bigger set. So let's say that I'm expecting that my codomain is range. I'm expecting that all real numbers can be output. But what is my actual output? Y is equal to x square. That means I will only get y as non-negative values. I will only get y as non-negative values. That means this is my y. So my range is nothing but 0 to infinity. So you can see that range is a subset of codomain. Range is a subset of codomain. Now, graph comes very handy in finding out the range and domains. How? Y equal to x square. The graph is like this. We can see that it will be taking all the values of x, whether in positive or whether negative. But for y, it will be taking only positive values, no negative values. Now, in order to find domain, you have to do this. You have to put the values and you have to think that okay, which are the valid inputs and which are the valid outputs and which are not. But in order to find the range, you can do one thing. What you can do, suppose this is y is equals to x square. Here what I am doing is I am putting the values of x. I am trying to find out that what values of x I can place. Now you can do the reverse as well. Let's say that this is my function, and I am writing this function as like this. Now observe what values y can take. What values y can take. Obviously, because y is in the root, so y cannot take any negative values. So when you change the function, this method comes very handy in finding the range. Now you can think that what values of y are acceptable. So you will say to me that because there is a square root, so only positive values or non-negative values of y are acceptable, and that is what our range is. Non-negative values. So this is one method. Let's take one more example. If you're still not getting it, let's take one more example. Let's talk about this function. Now, let's look at this part. 1 upon x square minus 1. As I've said that there are some values which are not the valid inputs. Why they are not the valid inputs? Because the corresponding output that we are getting is invalid, or we don't know its value, or it is an indeterminate form. Now, some of the indeterminate forms is, suppose that 0 by 0, we don't desire 0 by 0, 1 upon infinity, or 0 into infinity, or infinity by infinity, or 1 upon 0, sorry, 1 upon infinity is okay, 1 upon 0 is not okay. So these are the some of the indeterminate forms that we do not desire. We don't know what their value is. Okay, so let's say, okay, 0 into infinity can be done as well, because it's 0. So let's say that these are the indeterminate forms. So we don't want any of these forms to occur. We don't want any of these forms to occur. If these forms are coming as our output, then they are not acceptable. Now look at this question. If I put x is equal to plus minus 1, what happens? For x equals to plus minus 1, y becomes 1 upon 0, and this is not desired. This is an indeterminate form. This is not desired. That means x can take all values. Now I don't mind putting here a very big positive value or putting here a very big negative value. But I cannot put x equals to plus minus 1. So x belongs to minus infinity to infinity except plus minus 1. This is my domain. Now again, I am expecting my range to be R. Again, I am expecting my range to be R. I am thinking that my y will belong to R. So this is my codomain. That is what I am expecting. But look at what is happening in actual. But in order to find a domain, let's convert the function. So x square minus 1 is equal to 1 upon y, and x square is equals to 1 plus 1 upon y, and x is equals to 1 plus 1 upon y root. So this is the conversion. Now obviously I know that 1 plus 1 upon y have to be greater than 0. 1 plus 1 by y have to be greater than or equal to 0. That means if we solve this inequality, that means minus 1 plus 1 upon minus 1 upon y should be greater than equals to minus 1, and if we inverse it, then the inequality will change. That means y must be less than equals to minus 1. So y will always be less than or equal to minus 1. Okay, y cannot be y, you cannot put any value of y that is greater than minus 1. Y is always be less than equal to minus 1. So that means my range is actually minus infinity to minus 1. We can get minus 1. We can get minus 1. If we put x equals to 0, then we'll get minus 1. So that's it. So there is no problem in it. But y will always be less than equals to minus 1. Okay. Now that means y plus 1 upon y, okay, it has to be greater than or equal to 0. That means if you cross multiply, y has to be greater than equal to minus 1. So that means our range is minus 1 to infinity, where minus 1 is included. So you can get any value from minus 1 to infinity as your output. So this is the best method to find out the range. I hope that you have understood how to find out the range and domain and codomain. This is the very basic thing of the chapter functions. Now you are going to use these things at many times in your calculus as well and in coordinate geometry as well. The most important thing to note about this is that it is relating to functions, and if you want to find out the range and domain, graph can help you a lot. Graph and then your activity in how are you looking at the question. If you want to find out what are the acceptable values of x, try putting values here. If you are trying to find out what are the acceptable values of y, try putting the values of y here. That's it. You can do anything. You can try put the values of y here. Now, if you see this, then this is the thing. Then 1 plus 1 upon y has to be greater than or equal to 0. That means y plus 1 divided by y have to be greater than or equal to 0. Now again, this is an inequality. When we solve this inequality, how can we solve it? This is minus 1, this is 0, and this is positive, and this is positive, and this is negative. So that means my y actually belongs to minus infinity to minus 1 union 0 we cannot include, 0 to infinity. Why we cannot include 0? Because y can never become 0. You have to put a very huge value like infinity, which will become 1 upon infinity 0. And similarly, if you can see here, 1 upon 0 is not allowed at any moment. So obviously you cannot put 0 here. So this is the value or range for the function. Now this is the best method. If you want to find domain, try putting the values here and analyze the values. If you want to find out range, put the values here and analyze. So I think this is the best method to find out range. Now again, we have different functions who have different complications, but that can be ordered. So I hope that you have understood this, and it is actually a very important concept. You are going to use this very frequently in coordinate and as well as in calculus. So I hope that you have understood, and this is it for this lecture. So keep solving the questions and good study along. Thanks. Bye bye.